Hi guys, today we're working on 7.1a and b, and these are both working on rational expressions. 7.1 is determining excluded values, which we'll talk about what that means in a second and what rational expressions are. And 7.1b is reduce the lowest terms, which we call simplifying. We've been doing that for a long time. Okay, so a rational expression is just an expression that can be written as p of x, and I just picked a random one, equals r of x over s of x. If you'll note, we have a ratio, hence rational, or which can also be known as division. Don't forget that ratio is just division. So we have a ratio of two different expressions. So an example of one of these, we might have 3x squared over 4. We might have 2x to the 5th over 3x, which we could then simplify some more. So these are examples. We could even have something as complicated as like 13x to the 2nd plus 2x minus 5 all divided by 2x plus 1. So these are all examples of rational expressions. They're expressions that have a ratio in the middle. We're going to specifically deal with ones that have x's and y's, or whatever our variables are, in the numerator and denominator. So then we talk about this thing, determine excluded values. So if we have a fraction right here, right? One of our principal rules in math is we cannot divide by 0. So the excluded values are values for or in which the equation cannot be evaluated. As in, we can't plug that process in because we're going to divide by 0. So if we look up here, so if we say for p of x equals r of x over s of x, our excluded values, our excluded values are when s of x equals 0, which we can then solve this equation. So if we had 4 in the bottom, we have 4 equals 0, or 3x equals 0, or 2x plus 1 equals 0. So what we say is, therefore, we can say that whatever is in our denominator, and I'm just going to call that s of x for this time, it cannot equal 0. And this equal sign with a 9 through it just means not equal to or cannot. It just negates the equality portion of it. So to find these values, we're just going to figure out, using our nice algebra skills, what denominators we cannot have. So example 1, we've got directions for each of these three examples. Example 1 is 25x squared over 45x to the 5th. Part A is going to be determining the excluded domain and values for a rational expression, which is exactly what part A is up here. And part B is going to reduce the lowest terms. So you're going to want to determine your excluded domain values before you simplify. So it's not as big deal here, but it will be in the future. So let's just practice taking our denominator. So part A is we're just going to take the denominator, and we're going to say if this cannot equal 0, so therefore we can just solve this equation. So 45x to the 5th, we're going to divide by 45 on both sides. 0 over anything is 0. So x to the 5th equals 0. And the only thing that multiplies by itself 5 times b 0 is, of course, 0. So we can take the 5th root if we want to. It's probably the right way to do this. Something to the 5th power is undone by something to the 5th root. The 5th root of 0 says x cannot be equal to, oops, don't forget my cannot sign, x cannot be equal to 0. Pretty straightforward for that one. So what we're saying is we can't have anything raised to the 0 power, or 0 raised to the 5th power is 0, times 45 is 0, which we would then be dividing by 0. We're not allowed to do that in math yet. I'm just going to say yet. That's part A. Part B is reduced to its lowest terms, so just like we did in the past, we're going to say, 25x over 45x. So we're going to cancel out our pair of x's. We need 25 and 45 are both reducible by 5. So we divide the top by 5 and the bottom by 5, which is really dividing by 1 because it's the same thing over itself. We're going to get 5 over 45 divided by 5 is 9. We have no x's left in the top and x to the 3rd in the bottom. So this is the reduced lowest form, 5 over 9x to the 3rd. And this is something we did back in Unit 3, so this should kind of help us out. Speaking of Unit 3, we're doing a lot of factoring, so let's practice a little bit of that now. One of the ways, so this is example 2, 32x to the 4th plus 16x to the 3rd divided by 32x to the 4th plus 48x to the 3rd. Don't forget that one of our methods of factoring is with GCF. So we're going to practice factoring this one by GCF, and that's one of our ways. So don't forget factoring by GCF. And you're like, Mr. Seaman, I forgot factoring by GCF. Then I'll have some stuff in the folder for you to help you remember how to do factoring by GCF. I'll point you to a couple websites and get you some good information so that you can practice that. So we're looking for the greatest common factor, which is the biggest term or terms that multiply to be any individual term in that polynomial. So we're just going to look at these one at a time. I'm looking at the numerator first, factor that by GCF. Then I'll look at the denominator and factor that by GCF. But first, I need to figure out the excluded values. So we'll take our bottom. We're to say cannot equal to 0. So this is a kind of a hard problem. So let's factor by GCF here. Let's see if that helps us. So we got 32 and 48. Let's see, we get 16 goes into both of those, so 16. We also have 4x's here and 3x's. Okay, so x to the 3rd can multiply by 1 to be here, and x to the 3rd can multiply by x to be here. So x to the 3rd is our greatest common factor. So 2x multiplies it. 16 times 2 is 32. X to the 3rd times x is x to the 4th, plus, let's see, 16 times 3 gives us 48, and x to the 3rd times 1 gives us x to the 3rd. So this cannot equal 0. So we've got two things that it cannot. So I'm going to break these into two different equations. This can multiply by this, so we use a zero product property to say that either 16x to the 3rd cannot equal 0, or 2x plus 3 cannot equal 0. So this bottom one, divide by 16, we get 0. Square root is, cube root is 0, so we get, let's see, so divide by 16. We get x to the 3rd equals 0, and the only thing that multiplies by itself 3 times by 0 is, of course, 0. So x cannot equal 0 is one of our excluded values. Let's say the other one, we're going to subtract 3. We're going to get 2x cannot equal negative 3, so x cannot equal negative 3 over 2. So this one, we have 2. We have x cannot equal 0, and x cannot equal negative 3 over 2 for this bottom part, which says that those are excluded values. So then if we're going to reduce our lowest terms, we're going to factor by GCF. So we already factored the bottom by GCF. So I'm just going to write the bottom is in 16x to the 3rd times 2x plus 3. And the top, I'm going to factor the GCF as well. It's like 32 and 16. Biggest number that can multiply to be either is still 16. X to the 4th and x to the 3rd is the exact same thing at the bottom. X to the 3rd can multiply by x, and x to the 3rd can multiply by 1. Okay, so 16 times 2 is 32, and an x to get us x to the 4th, plus, let's see here, 16 times 1 gives us 16, and x to the 3rd times 1 gives us x to the 3rd. So that looks like to be the factored form. So if we're simplifying it, we're going to cancel what's on the top and on the bottom. So we have 16x to the 3rd is multiplying by 2x plus 1, and 16x to the 3rd is multiplying by 2x plus 3. So just like we can cancel 2 times 4 over 2 times 3, we can cancel the 2's. We're going to do the exact same thing down here. Because this is all multiplication, we're going to cancel out what is exactly the same in the numerator and the denominator, which is 16x to the 3rd. So we're left with just 2x plus 1 over 2x plus 3. And if you ask me, Mr. Seaman, why didn't we cancel the 2x's? This is one whole term. So yes, it's one multiplication thing, just like 4 can't cancel 3 because it's one entire part of it. Then this is also one entire part of it. So we're just going to leave just like this. So this is the lowest form of this original problem. So we've got two excluded values, x cannot equal 0 and x cannot equal negative 3/2. And we also have the simplified form. So this is factoring by GCF, and this is one of those things that you'll have to do. I'll throw some more practice in the folder for you if you need it. Okay, let's look at our last example, which is example 3. X to the 2nd plus 3x plus 2, all divided by x squared plus x minus 2. So I'm going to try to factor this first. And don't forget we can factor this using trinomials. So I need numbers that multiply to give us, what's that, 2, and add to give us 3. So Multiplies to give us 2 is 2 and 1 and 2 and 1. So multiplies to be 2 are 1 and 2 and negative 1 and negative 2. So that says that we've got, I think it's just that option. That's the only one we can have. So yeah, so 1 times 2 gives us 2, and 1 plus 2 is 3. And in the bottom, multiplies to be negative 2 and adds to be 1. Okay, so negative 2 is to be 1 and negative 2, or negative 1 and positive 2. So we're looking for which pair of these. Let's see, they both multiply to be that, so I need ones that add to be positive 1. So 1 minus 2 is negative 1, but negative 1 plus 2 is positive 1. So we're going to say negative 1 and positive 2. Okay, so then remembering back from Unit 3, gosh, it's been a long time ago, we do x plus 1 all divided by x plus 2, or all times x plus 2, all divided by x minus 1, so minus 1 and plus 2, and x plus 2 down here. Okay, so let's figure out our excluded values. So it says we're going to take our denominator, which is x minus 1 times x plus 2, and say this cannot equal 0. If it equals 0, we're dividing by 0. We don't want that. So again, the zero product property, something multiplies by something else to be 0, which says that something has to be 0, or something else has to be 0. Okay, so we're going to add 1. X equals 1, and we're going to subtract 2, or sorry, cannot equal 1. Subtract 2, so x equals, let's see, negative 2. Oh, nope, cannot equals 2. So we have our excluded values of x cannot equal 1 and x cannot equal 2, which you can also write as x cannot equal negative 2 first, because it's smaller, and then 1. So either way of either of these or this is a fine way of writing this. Alright, part B. We need to simplify to its lowest terms. So we factored this up here, so x plus 1 times x plus 2, all divided by x minus 1 times x plus 2. So again, we're looking for what we can cancel. What's the exact same on the top and the bottom, inside the parentheses? And I know this x plus 1 and x minus 1 are not the exact same. One's a plus, one's a minus. The other one is x plus 2 and x plus 2. So I'm going to cancel both of those, leaving me with just x plus 1 over x minus 1, which is the most simplified form of this. Okay, so I feel like setting the bottom equal to 0 and solving, we can do that, but I feel like the factoring is definitely the hard part. So if you need help factoring, in 4.2b, finding roots by factoring, that's still in our folder. And other than that, I'm going to toss some other videos into the folder, and I'll put just like, I'm going to call them factoring review, and then I'll do a dash, and then it'll just be some name in there. So work on any of those that you might need to. And then best of luck to you. I'll help you as much as I can.